Good evening, guys. Good evening to everybody who is watching us over the internet. How are you today? Great. Who feels great? Less hands. Okay, everybody feels great. Okay, you're kidding, right? Okay. Bad joke, bad Valentine, bad Valentine. Don't do this anymore. um, yes, it is sad that we didn't meet each other early, but I hope we're gonna catch it up, right? So everybody understand what I'm talking. I'm not talking too fast. I'm not talking too slow. I'm not talking any bullshit that you think it's what he's talking about. So Thomas, my name is Thomas, as you guys can mentioned already. I'm from Silicon Valley, and here is my friend George. He's not from Silicon Valley, but you know that he looks like he is from Silicon Valley. Don't mess it up with it. We're going to talk to you, and you're gonna talk back to us. That's what we do when we teach lectures, because I'm a professional teacher. You must remember me from the first time we've been here. I told you that everybody is here not a professional teachers but me. So I am the only one who is a professional teacher. That guy knows, so he's smiling. Everybody doesn't understand that, so that's okay. You know what professional how you know how to distinguish professional teacher and not professional teacher? No, okay. So professional teachers. No, not professional teachers. They usually have slides, right? So slides and materials. It is not professional teachers. Professional teachers, they don't have it. So they have nothing, right? So they think that nothing is needed, nothing is important. So I don't have slides. That's a good point for you, but I do have something that I want to tell you. This is first thing, how to distinguish professional and non-professional teachers. Second point, how to distinguish professional and non-professional teacher, is that professional teachers makes people work, and he is not working by himself. So I want you guys to work today, and for me it's a great time and leisure. So that's why I brought this pail of papers. So please share 2 papers per 1 person. I think that will be enough. Share it with the whole group. We're gonna do it old-fashioned. Two sheets. Don't think like those who doesn't understand English very well. Sheets, it's not what you think, right? So it's not this crap or shit. So this is sheets. Piece of paper. You're gonna need 2. And I want you, everybody, I want you to have a pen or pencil, doesn't matter, but we're gonna do some exercise at the moment. If you don't have pen or pencil, raise your hand. I have 2. I can share. You are the first one, okay. I want you to give it back. Okay, so those are 2 my favorites. So the black one, the blue one for you, okay. Everybody has now pen and a pencil? There's a pencil and a pen. George, do you have a pencil or a pen? You want to participate? You're not going to participate. Okay. Okay, don't spoil it then. Good. So it looks like, Valik, what we do when we lost signal from the computer? Okay, it's back. So please work. Just, you have everything that you need. I do my job, you do yours, so we good. You don't know what to do, right? Most of you are students. So who are not student? You are not student. Okay, good for you. But for the rest of the people, I think it's okay when you do some exercises on the lecture, because people who are not students, they usually get really lazy, so they want to work. And like when they go to seminar or workshop or a lecture, they don't work. They just sit and still, like, okay, teach me anything, like show me how it works, show me some magic. After this exercise, I want to become a Ruby Jedi. it's not gonna be like this. Okay, so we going to talk about unit tests, and I don't know how much you know at the moment. Okay. I bet why do you use this thing? Tests. Tests, and specifically unit. Unit tests or unit testing, this is the topic for us. What do you know about it? Nothing. Who knows anything about tests or unit tests? You do. Okay, what is that? So we write the first definition. Unit tests or tests, when we write templates for, we check if it passed or not. My work. If we think about like not just unit tests, if we think about tests, what is that? What do we call test in real life? What do you test? Like, do you test anything every day? Like, is it something that is part of our, you know, day-to-day work or daily basis or your life? What do you test? What do you test? Labs? Labs or lab dance? No? Oh, laboratories. Okay, lab work. Okay. Good. What else? So when you cook your eggs in the morning or you make a soup, right? You want to test it out. Is it ready or not? Is it enough salt or not? How do you test it? Like you have sensors in your mouth, right? So you take a spoon of soup and like, oh, it's not ready, or it's ready. I need to put more salt or more paper. I need to cook it like 15 more minutes. How do you understand that you need to cook it 15 more minutes? You have a system, right? So you have like really complex system inside of your body or inside of your head. So I know how to test my eggs, or I know how to test my cereal. I know how to test my soup is ready. So when you cook, it is clear. I cook my soup, I know how to test it. When you write your code, how do you test it? You just run it, okay, it looks like it should work, right? So how do you understand that it works? By your gut feeling. So it's like, I hope it works, right? So it looks like it should work. But you don't have like specific sensors, right? You cannot taste, like, you cannot bite your program. You cannot smell it. And in this case, like, I don't know if you heard, like your code smells. It smells bad. It means like it is not perfect code. So code smell, it is even a term that you should use in the future. So tests, this is like complex system as you have in your body to test your code, to make sure it is ready. You can eat it. It's in a good condition. Why we need it? Like if we can just, you know, write our code. For example, if you write your code not for you, right? So you cook soup for yourself, right? So you can test it and think, oh, I like this soup. Maybe it's salted not enough. That's my soup. I feel pretty comfortable with this particular soup. I'm not gonna share the soup with anybody else, so I'm okay with this kind of a soup. For example, if you invite anybody, like your parents come to you, or parents of your girlfriend or boyfriend come to you, and you want to make them soup. Think, okay, should they like the soup? What are their what they prefer better? What are their preferences for the soup? And your system are changing, and it's going to be more complex, right? So it's not enough just to have soup salted enough. You need to put like broccoli inside. You need to put, you know, any kind of ingredients there. What if you want to sell the soup? What if you want, you know, sell the soup for 100 people? You need to have like a big bucket, and you now need to create like a massive soup production mechanism. And you cannot just test it in your mouse, right? So your built-in testing system is not enough. So this is exactly what happens when you code, right? So if you code for yourself, like you code and you enjoy, you can test it, like just run it and get quick feedback. If you code for your friend, so if I code for George, right? So and we meet each other, and George said, "Hey, can you code a little bit for me?" And I said, "No problem. Like I can little bit code for you." So that's okay. I know like what he likes, and we can code to each other. It's okay, right? So pair pro. Oh, okay. Yeah, somebody called it pair programming. But if we code for life, right? So if we code and we sell it to our clients, or we code for people who's going to use that massively, we cannot rely on our eyes, on our smell sensors. We need to have something that can say, all is good, taste is good, your soup is ready for 1,000 people at the moment. And it's very actually tricky. Nobody likes tests. Nobody. When you go to work and you are told that you have to write tests, usually people prefer not to write tests and do cowboy coding, right? So I code first, then I cover that by test. Yeah. Thomas. My name is Thomas. I am rich and I have a yard, so I'm a rich yard Thomas. Okay, that's a good one. Let's listen to the gentleman with the microphone, okay? Because like everybody doesn't listen that. No. When you get enough confidence to understand what you do, when you understand that you're making soup, then you would love to do tests. But when you start doing your first job, you're doing something but you do not understand. If you can imagine, like when at your first job you go to the kitchen, like it's a big kitchen, it has everything that you need to build anything. You can build a cake, you can build a salad, you can build a steak, and you start doing something but you don't understand what you do. Like you start cutting tomatoes, 1 day cutting tomatoes, 2 days cutting tomatoes, 3 days what I'm doing here, right? So I'm just cutting tomatoes. And then you say to your manager, so I'm tired to cut tomatoes. Can I do something? Like, okay, cut cucumbers. So like you're cutting tomatoes, cutting cucumbers. So and what George said, that people start, those people who understand what they do, like I understand I'm doing part of a salad, right? So I'm cutting tomatoes because it's going to be a salad. And there is not a guy who is cutting, cabbage or who is doing something. But at the very beginning, you do not understand that. And you do blindly. You do something and somebody asks you, hey, you need to start writing tests, and you don't like it at all. I will give you example why it is important. So take this sheet of paper, first sheet of paper, one. And this is your first task. So I want you, like everybody, to draw a person, a human, and the house. One person and one building. A human and the house. Like 1 minute for you, just draw it as you see it. A person and the house. Those guys who are watching us over the internet, take a sheet of paper. Don't think about sheet of paper as something bad. Think about it as something good. This is like piece of paper. And draw a person and the house. One person, like a man, and the house, like a building. The one that you like more. Go to the comments, send it to us, or send directly to the Telegram channel. We're really happy to see how you can draw a person and the house. So you have 1 minute for that. A person and the house. Okay, well done. Not bad. Yeah, yes, George, yes. You'd like to draw a person in a house. Okay, let's George draw a person in a house. Okay, you do the same. Do it at the same time. Yes, a person and the person. Here you have more markers. Okay, everybody but George completed the task, right? So everybody has the person, and the house. That's up to you. No problem. So what we've done recently? Would you like to draw a person in a house, gentlemen? Try one. It's fast. Okay. Thank you. Thank you, George. You're useful as always. So what is that? So what you've done right now? Can you raise it and show it to your neighbors, to people who are sitting next to you? So this is my person in the house. Okay, this is my person in the house. Okay, it's my person in the house. Okay, do you have any similar pictures? Can you recognize any pictures that are similar to each other, like identical? Not really, right? So you have those you guys have similar, very similar. Okay, it's good. So what we've done recently, this is Ruby, clean and simple. You can use this sheet of paper to solve problems. You can do whatever you want to do with Ruby. You can throw it in the garbage, or you can have a beautiful painting and sell it for $1 million. This is something that can help you to solve problems. A person and the house, it is a problem. I'm your client. I'm asking you, draw me a person and a house. Use Ruby. And everybody now implemented it how they think it should work better, right? So before you start drawing, you think, okay, how do the person in the house? Maybe the house has a roof, person has a hat. Another could be small. You use really small size of the paper. You save paper and save Ruby. You implemented that efficiently. You use the whole picture, right? So that's my space. I implemented. I have 8 gigabytes of RAM, so I use all 8 gigabytes of RAM to implement this simple task. So you implemented it differently, right? But then I ask you a question, everybody implemented a person in a house. Now raise your hand if you can fit, if your person can fit into the house. So how many of you implemented this part of your program that they you can fit your person, if your person inside of the house already? Well done. Raise your hand as well. Okay, raise your hand if a person can fit into the house. Okay, so it fit into the house. Okay, keep your hands up. So this is the first test. Not everybody passed it. Then keep your hands up if your house has a door. No. If your person doesn't fit into the house, there's no point to have a door, right? So sorry. If you have a door, then if your person fit into this door. Okay, 1. You're a lucky one. Can I see your? Really? Okay. That's okay. That's a feature. It's not a bug, right? Perspective is a feature. And then I can ask you more questions about furniture, about windows, about anything else. So nobody asked me what are my requirements for this particular task. You consider that's very simple. If I ask you, hey, I need a shop. I want to sell T-shirts, or could you build me a website with green button? Everybody understand that perfectly. Okay, I need to build a website and a green button. So here is your website and the green button. And then your client say, I don't like this. I want something different, right? So I want this website to be different. I want this particular house to be different. You never ask about it. You cannot test it. And then you think your client is asshole. So he's talking. he's not a technical guy. This is the perfect person in the house, right? So that's my really best person in the house, and I'm not gonna change my mind. So I don't really care what you're looking for. So that's a very dangerous, like this is like really slippery slope, right? So that's very dangerous situation when you perfectly understand a task, but you don't know how to test it against requirements that your clients or your customer or anybody who's asking you to do that really ask you to do. So now takes the second sheet, or turn it around. Now you know my requirements, right? So a person should fit into the house. It should have a door. A person should fit into his door. It has a window. Window should be at least bigger than a person head, so it can see through this window. And I've seen there is not actually a person, so it's a person with two legs. Everybody has two legs. Not usually people draw a person with two legs, right? So we understand that it's a person with two legs and two arms. So this is a normal person. Draw it once again. So you know the simple requirements. Draw it once again.
Should the person be in or out?
That's a very good question. It's going to be out.
Do we have any
5 points to you. You're asking questions. This is a very good question. No. See how it works, George? It works like a magic. Oh, let me go to the internet. Hello, guys, into the internet. We just completed this first exercise. So if you sent already, let me check it actually. If you sent already a person in the house, I don't see it actually in the Telegram group, but I hope you do. So now, draw the same exercise one more time. A person in the house, person should fit into the house, it should have a door, person should fit into this door, it should have a window, and the window should be a little bit bigger than the person had, so he can see from the window. Okay. Okay, ready? Now show your pictures to your neighbors. Can you find like really similar pictures? Okay, one window and one door. Not bad. Smiling. Okay. Nice. Good. Okay. So what you've done now, right? So we had simple requirements, right? And you know how to test your code. You know how to test your program against those requirements. Use your eyes. Like, really? Is it feel like it's bigger? Really big? Okay. It fit into this door. It fit into this house. So it works pretty well. You good now. So how do we use that when we program? When we do programming, how do we use same idea for programming? When you start coding, right? You have idea what you do, like in your head. So I need to code green button, or I need to code form that I'm gonna submit. I need to code text area. Whatever, any elements you want to code. And then you think, okay, how it should look like? It should be like that big or this big. It should have text on it. When I click, what happens? So in your head, you're just spinning ideas about how it should behave. Instead of thinking about it, you should write it down. And even though you can have technical requirements as part of your project documentation, it is your responsibility as engineers to translate those technical requirements into a piece of code that can test elements that you create. So in other words, instead of writing code once, instead of just drawing a person and the house, you write code 2 times. First time, how do you verify that your code works? And second time, your actual code. And that's really the steps that you have to remember and follow. You write test first, and then you implement your code. So you write your test first, it fails because there is nothing, right? Then you write your code, run your test again, and check that it works now. So if I'm an engineer, right, and George is a computer, George, can you help me with that? And
You're a wonderful drawing teacher.
yes, and this is Ruby. So George knows how to interpret Ruby. You are a computer. Could you take like any
I'll take all.
drawing?
Winners take it all.
Yes, winners take it all. So it looks like. Give me one.
No.
And it's just please give me
Yes.
one. Okay. So how would those tests look like?
You need to use correct command.
That's exactly right. So if George is a computer and we are human, we send commands to the computer. So how would look my test? So George actually very smart. He knows how to do anything, but he's very complex in communication. We never tried that before actually. This is something that we're doing first time. So then I'm gonna test. I show you how do we write code in the test. So first, hey George, does the person exist? This is your code. Does the person exist? Is there any person you have?
No.
No. So this is my first test. Does the person exist? No. So George says no. And then, so my test fails. And then, second step, draw a person.
I guess you could separate it from. You can separate. You can distinguish. You need to distinguish your program and your test.
You're a Microsoft program, right? So you're starting helping me when I don't ask you. No, stop doing that. Stop.
Person
We are not teaching them .NET, right? So we're teaching them Ruby.
where is the test?
Let's switch the roles. Okay, it's gonna it's gonna to nothing. Okay, I'm gonna be a computer. So you're gonna be an engineer. Okay, okay. Show me cats. No cats. Show me what do you say, like? show me cats. Never mind. Okay, sorry. Okay. Yes. Does the person exist? No. Right? And then you ask, draw me a person. So I am, as a computer, consider a person to be an object. So I don't really care. What is that? So hands and legs and everything else, it's like decoration. So for me to pass his test, does the person exist? Yes, because I consider it to be a person. Okay, what is your next test?
Does the person have legs?
Let's keep it as is. Let's go to the house.
Does the house exist?
No.
Draw the house.
Draw. Okay, draw a house.
Now computer command. Okay.
House. And that's actually the steps that you need to perform when you start coding. You don't create a person, as I said, with baseball hat, curly hairs, and so on. Does the person exist? Yes. Does the house exist now? Yes. What is your next condition, George?
Does the house have doors and windows?
Doors and windows. Okay. It has doors and windows. Like this.
Do they align? Do doors and windows align the house? Are they inside of the house?
That's okay. Don't overcomplicate it. So actually, doors and windows, it's just an element that I create. You don't really care that it's aligned. There is no design style, right? So it's like door and the window. Okay. It is a house.
I'm overcomplicating.
You overcomplicating.
But at the moment, I'm not sure if I computer.
No, I'm the I'm the computer.
Probably I am synthetic life or something like that. I can't prove it. Like
What should be the next question that George should ask me?
Am I human?
How do we test it next? So this is a person, this is a house.
Does a human fit in?
Exactly. Does this human fit into the house? No. And so make the house length, and that's how a computer understands it. Make the house length bigger than the person length. Does the person fit the house? No. Then make it heights bigger than the person. So now, does the person fit the house? Yes. So now you can place this object into this object. And then you start thinking like you are evolving your program. Can this person fit into this house? Yes, but how this person get in? Is there a door? No. So let's build a door. Let's draw a door. Does this person fit into this door? Yes, it can fit into this door. So what we actually created in this simple model. So this is a person and a house and a window. In the minimum required scenario, this is what your client are looking for. It doesn't look for legs, it doesn't look for style, and sometimes it's not even your work to think about, you know, all the styling. You have to think about models and interactions. What are the models we have here? Name it. What are the models? How many models we have? 2 models. Okay, let's start with 2, then with the couplet, right? 2 models. Which one? What are the models? A person and a house. Okay. What do you think? Like window and the door, right? So that's your okay. The property of the house. Could be an object. Could be. But let's consider that.
Okay.
What are the interaction we can name for person and the house? Fit. That's the property. But how? What I mean, like interface. Do they have any kind of interfaces? How it is not required? We're asking, does it fit or not? Or can fit? Okay. So, how would you name this interface? How they interact with each other? So, how do you interact with your house? You go there, you open the door, you get in, you close the door, right? So that's the interface. You not agree with me that the door is the interface? You get into the house using the door, right? So if there is no door, you cannot get in. Even the house can fit for you, but it's box. Door is the interface. No objections. Window. Is this an interface? It is. Like he can walk through this window. It's like read-only interface. You cannot get in, but you can see what is inside of the house. If there is many houses, you don't know which one is yours. You come to this house, look into this window. Okay, there is my, something. I can get in. So that's my house. And this drawing is different from what you have, right? So it's different. And if you now understand how it works, let's try to put this example into the code. And George is going to help me. Lucky you that you do not need to implement. It should be a little bit nicer, I think, but this is something that George implemented here, what we call test scenario. To test everything that we discuss, it is actually a piece of code that you need to write down. And to execute this code, we need to have a tool, like a library or framework or something that can interact with your objects from your code and poke it. Like, what is your size? Do we have a door? How to open the door? Can I open the door without a key? Which key should I have? Is there any window? And so on and so forth. So this piece of code should understand how to interact with your program. And as I said, lucky you, because we have already built-in framework, which is called RSpec, which can help you to do everything that we discussed. So how RSpec? What is RSpec? If you go to hi guys in the internet. So we completed everything with the whiteboard, and now we will work with everything that you have on your screen. Don't worry, you didn't miss anything. So what is our spec? As you can see here, our spec is a gem. So first of all, if you start working with a blank program, you can get our spec installed as part of any other libraries that you have. So for example, if it's a Rails, then it's going to be our spec on Rails. If it's just a plain Ruby application, then it's one line in the gem file, and actually it brings you with a couple of generators. So as you can see here, in a couple of seconds, everything was set up and prepared in just in a few clicks. So to install our spec, you need to create gem file. If you have a gem file in your program, you just need to add a line, gem our spec. Then when you install it, you're going to have commands from rake tasks. If you use rake, you can initialize it with rake tasks, or if you install it in the binary folder with built-in, you can use our spec as a command, and command init will actually create folder spec, which is mandatory. This is convention, and it's gonna have our spec helper file, which have number of parameters in the same fashion as you would configure your Rails, right? So there is configuration, how to output, where to find files, how to treat any dependencies, how to work with mockups, how to work with everything. You don't need to really care about it from the very first time. The only thing that you need is to have two parameters, to have colored output, so it looks nice, like when you run your specs, you, oh wow, it looks like in a matrix. And actually, when you add your files, you need to treat this, or you need to carry on with this spec helper to add it into the rest of the files. So how does a particular test would look like? It is a Ruby code. So this is a sample of a code. And to create actually our spec, it would require you to have like empty file, require our spec helper, so the program knows where is the library exist, and then that's actually it. So let's scroll it back into the time and see. So what do we do here? So we create empty class. We can call it bowling here. It is called bowling. It class has attribute reader. I think you know what this command does, what this helper does, or this alias. So it creates for us reader method that gets back a number of the score, and it's create method hit. Okay. Then we create a spec file where we describe the class that we create and the method that this class has with the context, which means that we give it human readable context, how to understand what you're doing, at expectation. So what it does, it actually creates a new bowling object. 20 times it hit the score, and then at the end it expects the score to be equal to 80. You have no idea what is our spec. Can anybody explain me what is written down here? How should this program work? Is it clear when you just read it? So for example, if your mom, if you're anybody like who are pretty far from programming, read this code through, taking into account they know English, would they understand what is written down here? Is it clear? Right? Who can explain what is what should be here? What should this test test? Bowling score. Okay, what is the bowling score?
The score person gains.
Okay, when you hit it, what it does? When the score hit? You don't remember, right? So we can see in the method itself. When yeah. I think it counts the score. Okay. This editor doesn't show it well. But what actually it does, right? So it populates score 20 times with heat of 4. It means like every time when you do it, add 4 to the score. Plus 4, plus 4, plus 4, and it does it 20 times. And then, could you explain this line? What this line says? I expect from this program that the bowling score, after 20 times of increasing, is equal, or to it expected to be equal 80. It is readable, right? So when you read it, you can understand it. That is actually it. So this is everything that you need to know about RSpec. It knows how to work with your code because it has the same classes that you create in your program. So instead of going to interactive console, into Rails console, to any console and play by hand with creating object, I create bowling object, test it out, you write it down once. And when you change your program, you run your test separately and see, okay, it's still good, it still works. I'm not breaking anything. It has something weird, like it has this command which is expect, which means it's matchers. It has methods that can help you to validate. Don't get sleep. I'm watching you. Don't get sleep. I will tell to the internet that when you wake up, you'll be famous. I can make you famous. I'm a producer. Trust me. Okay, 5 score to you, George. Thomas, my name is Thomas. You, George. Thomas, I meant George. You are George. So it has a number of additional methods that can help you, like a spoon to taste your soup, or temperature measurement, and so on. And when you run it, it gives you actually pretty clear and simple output. So when you run your test, it says like class bowling method score with no strikes should have or should sum a number of counts. And we expect it to be 80, but we got nil, which is failure. Our program works incorrectly. Why it is nil? Because we never add any kind of a piece of code to actually work with that. Then we add this code, we test it again, and we see that, okay, now our program behaves as we expect it to have. So rspec.info, that's the website that you need to check out. It has instructions how to set up, how to get started. I'm suggesting you to not starting with Rails, because it gives you too many additional features, but to start with simple, like you can use existing application that you build, or you create a brand new application that you want. Just install it and play with it. To get like documentation for RSpec, you go to Google, you say RSpec documentation or RSpec matchers, whatever you get. There is plenty of documentation. This website is good enough. So you can use these Relish docs. It has everything, like with samples. For example, if you want to test out and you don't know how to test it out, you go there, you check it out, copy, paste, try it out, modify, and it works well. What do we do now? George and we're going to show you one interesting game. So, and I want everybody, I don't know if you have computers with you, but we show you how to play with this game. It is called Evil Coder. Evil Coder. That's the game that that we're gonna play. Evil Coder. You ready, George?
I'm almost ready, but I don't know.
Evil Coder. What does it mean? Now you know that you have to write your test first. But as George and I, we sometimes we code for each other, and he, how you say that? Pair programming, couple programming. We do pair programming from time to time. So this is good practice actually for you to practice the same as we do with George, right? Pair programming and pair programming. If on the interview anybody asks you, hey, have you done any kind of weird practices like extreme programming practices, you say, oh, I know one. This is pair programming. Thomas and George show me how to do that. And using pair programming, now we will we'll try it out. Best practice. I think you know best practices, right? So wash your hand, like do exercise in the morning. These are all best practices. We engineers, when we code, we also have best practices. Like don't mess up with PHP, like be careful working with database, backup often. It is all best practices. So one of the best practices for Ruby, not especially for Ruby, but for православные языки программирования, orthodox programming languages. It is called test first. Test first. And for you to understand this practice better, George and I will show you this beautiful game which is called Evil Coder. So for those who are watching us on the internet, how to get how many how many watchers we have? Should I care about the online? Mr. Valentine, sir, can you check please for us? Do we have any online watchers at the moment? Because we really care. We do really care. It is matter for us. Because every time I'm explaining something, I need to explain it once again to the people from the internet. Good point. One viewer, thank you for staying with us. Hey, send me send me a message, and I on the next Rubizza hangout, which is going to be next week, I owe you a T-shirt, very cool branded T-shirt. Well done. This is Valik. Okay, good. So so George and I, we will show you, as promised, this practice Evil Coder pair programming for test first using our spec. You will do that in your computers. So you need to set up gem RSpec, you need to create files and so on. We're going to use this online tool, CyberDojo. CyberDojo, this is tool for pair programming. It has multiple languages, so when you go to CyberDojo, you can create your dojo session. Dojo, or from Japanese dojo. Yes, if you have it. So if you have it with you, open it up. You will need that. But you need one computer for two person. Just share one computer for neighbors. You don't need like all the computers, just, you know, have one computer, two person, you'll be fine. I don't know if you have internet here. Do you guys have, everybody has the internet? No? Okay, then open Ruby interpreter, and they still need to have internet for, so no internet at all. Even like a little bit of internet, no? Okay, then see what we do. That's actually sad. I thought you should have the internet, but okay, no problem. Remember what we do. George and I, and I think we can share my laptop, or we can share a couple of laptops to try it out. But let's see first, and then you will repeat that. If you have internet, like if you can share it from mobile, I cannot share it from my mobile because it uses for online streaming. But if anybody of you can, you know, have unlimited internet, share it to everybody. It is like to just install RSpec. But we're gonna use the CyberDojo tool. What it does? You can follow what I'm doing now, and you can repeat that on your own. So CyberDojo has a number of um, languages. So if you want to, play with C++, with R, with Golang, with Java, don't play with Java, with anything that you like, but you don't want to install it on your computer, this tool has it pre-installed. So you can use any language that they have to play with it. So we need Ruby, right? So we need Ruby, and as you can see, smart people and good programmers created for Ruby a number of testing frameworks. So we have Cucumber, Minitests, RSpec, Test Unit. Those are same things for different purposes, right? So RSpec initially was for unit tests. Cucumber initially was for functional tests. So it is all kind of a big pieces of a pie. You will discover that later. Our goal for this session is to give you like very high level overview, but actually to attract you and like make a simple seed in your heads that test, it is not evil. Test is funny, and they save a lot of time for you when you do your work. Oh sure, yeah, just like this. And it has a number of exercises that you can practice. For example, if you're going to an interview and you want to practice any puzzles for code when anybody is going to ask you to code for them. What do we want to do? We wanted to do game of life, right? So does anyone know what is game of life? Yes. Everybody knows, right? Who doesn't know? Game of life. Conway, you don't know game of life? Really? Okay. So game of life. It is cellular game, and it looks like this. Conway's game of life. So when you Google it, it's one of the Easter eggs in Google that you can see. So you see here when you Google Conway's game of life, see here pixels like start evoluting. There are evolutions of pixels here, and you can even make it full screen. So I don't know if you can see it. Just a second. We'll make it work better, buddy. It's better. Okay. So you see pixels, right? And they are like, this one is moving. This one is moving. This one is like, it is called still life. This one is also called still life. So Conway's game of life, this is another thing that you can watch forever, like how water flows, how fire is burned, how other people is working. So this is one more. Like, so it's now actually a piece of art. It has 3 simple rules. Like, this game has 3 simple rules. Each cell has 8 neighbors, right? So it has 8 neighbors. If you can imagine it, if it's a cell, it has 3, and 2 neighbors. Each cell exists in 2 states, dead or alive. So like this one who are white here, they are alive. The rest blue are dead. If this cell, and they change their state every second, for example. So every second you recalculate their state. So if you have this cell and it has less than 2 neighbors, it has 0 alive neighbors or 1 alive neighbor, it dies because of loneliness. Like, it's very sad. It's nothing to, like George and I, like we always need somebody to be around us, because if George, that's a very good example. George and Thomas and George do not exist if there is no people. Like, if there is people around, they exist. If there is no people, there is no George and Thomas anymore. Yeah, so less than 2 alive cells, they die. because of loneliness. More than 3, 4 and more, they die because of overpopulating. So this cell doesn't have food, so it dies. If there is a dead cell, right? So if there is a dead cell, nothing exists, and it has exactly 3 alive cells, it reburns. So it burned. That's, for some reason, Conways think that to create a new cell they need 3 people. Human need 2 people. Cells need 3 people. That's okay. So it's just get alive. All the other states does not, all the other conditions does not change the state. So it's very simple, like 3 rules, and you can see that using this system you can watch evolution. So how they're moving, how they're evolving, how they exist over time, and from time to time people use this game of life to create art, to create something that is very beautiful. If you go to YouTube, for example, and you, oh, that's very dangerous actually to open, you will see the whole, okay. Bad. Okay, I will search it not to go into the YouTube. You know how to do that? That's very, like, this is very dangerous when you presenting to the internet your screen, and you, let me show you on YouTube, and bam, and you see everything that I was looking before. Yeah, it works. It works only for okay. Conway's game of life. Yeah, and like, this is just a couple of samples how people create. So you see the same structure, right? So they are moving somewhere. Those systems, they are producing those, like, people really start getting crazy from this Conway's game of life, and they really like create big populations. So they start thinking about what they can do using this Conway's game of life. Actually, nowadays, this kind of a system they called, or this is piece of science now, like not a big data science, but it's called complexity science. So complexity science, this is something that you cannot easily decouple and then analyze every piece. And when you analyze every piece, you can get like the whole big picture. So for example, like, scientists cannot reproduce and model ants or bees behavior. So they can reproduce behavior of one ant or one bee, like 10 bees or 100 bees, but they cannot model behavior like of a whole colony of bees. They don't know how they evolve. And this is actually, yeah, that's what they create actually with Conway's game of life. And this is the task they are called complexity. So George and I, we're going to show you how to use our spec to program simple behavior for this game of life. And you can do actually the same. So you can watch these later on. So now everybody understand the game of life, right? So everybody understand what we do. Good. So let's do some exercise. CyberDojo, if you have internet, good for you. Okay. So what do we have here? So CyberDojo has .rb file, which is just file where we can put our Ruby code, and it has file with _spec. This is convention for our spec file to run it all at one time and see what happens. Syntax highlighting. So what are we gonna do, George? In game of life, we have 2 major models. It is cell, right? So it has a number of rules, and the whole world, the board, where cells are located. So George, what do you want to what do you want to implement?
So I can't speak because I don't have microphone.
Yes, only one gentleman speaks, the one who has a microphone.
Yes.
But you can mimic, like, you can show me with your gestures, like, a cell. Okay, that's a good choice. I thought it's a big cell.
Like a gaming board, you play chess with it.
Gaming board.
Yeah.
Okay. Then how to play with evil quarter. So George wants to
Is it like evil officer and a good officer? So
yeah, it's like this. You never tried evil quarter?
no.
Really? Lucky you. I'm the only one who played evil quarter, but now
I thought
George and I, like Thomas and George, will do evil quarter, and you can say, like, I've seen how to guys actually one time play evil quarter, and then they, put recording on the internet.
then it will be two evil quarters actually.
No, it's like it will be one evil quarter at a time.
And actually it will be two evil quarter and two evil quarter is me. Like, I'm two evil.
Two evil quarters.
Two evil quarters.
So what I'm doing, everybody can see what is happening here. In F sharp, you need zoom in out. No, good.
Call it hello world.
Why it is hello world if we implement the world? That's the okay. Hello world. George wanted to be hello world. Okay. Then the context, we're going to implement board of cells. So everything that you have here as a string, this is something that helps other people to understand what was your intent, what you wanted to put here. For example, if you start cooking your soup, right? So for example, if I'm cooking soup, and I put already, everything that is needed, and I only need to wait some time, and I tell George, hey George, can you watch for my soup, right? So I need to call, or I need to go to buy something. Can you complete, cooking of my soup? George has no idea. Did I put salt or not? And so this is like in the code, when you read through your tests, you understand what was implemented already, what works, and what is not. Board of cell, and I want this world exist. It exists. So I implement actually test first. So I want to create new world, and I expect this world to exist, right? So I have no idea how to check exist it or not. So what I'm doing here, go into matchers or spec expectation, and I see, okay, it's too much to be between, and I see like, okay, I can check it with be instance of, right? So I want this object to be instance of. It means like this object is created from a particular class. It looks like this one works for me very well, George. So I want this this world to be instance of world. It looks like my test is ready. So this is first test. This is what we've done. Does the world exist? And when I click button test, okay, it's very complex, like like a world. Okay, it fails. You see here, right? It gives me a red answer and explanation. So it tests hello world, and it says initialize constant world. So the world does not exist. At this stage, I take hands off and I say, hey George, now you deal with it. So I create a test that fails. What George needs to do right now? He needs to solve this test, to make this test pass, and write new test for me, which is fail. And then we change. So then I need to change, fix his test, and fix his code, and write the new test for George. So please.
Are you going to give me a microphone?
Yes, I'm gonna give you a microphone. So now you're the main gentleman.
Now the power is mine. Ha ha ha! Evil, two evil coder. So talking about this lesson, you are sitting here and laughing, and it's funny topic, but it's very serious, and I wouldn't describe it with any pictures, because this topic really helps you to be a good programmer. So if you produce code and you want this code to be useful to other people's, you need to write tests. So this is not just a good practice. This is like mandatory practice in all good places, like whatever you can imagine about good IT place, like Google, I don't know, NASA. But by the way, talking about NASA has their best practices, and they will not accept any code without tests, because tests help you to not only check your program, but also emulates the environment around, and this will allow you to prove that your code works on the in different environments. So you can't test your space shuttle in space, building it on in your docs, but you can simulate the environment of the space and test if the shuttle will not break. So finally, code. So being honest, I would like to start from this point, and I don't know what we have been doing for an hour, but sorry guys. So do you want to make a break before two-level coding? Okay. So one of the greatest things that test brings to you is that they allow you to imagine what do you need to do. So you know that you write the class called world, but how it should behave. So and now you can understand it from using it in your tests. So for instance, you can write not only a test about existing. By the way, nobody will accept this test because it's kind of very straightforward. But we'll create another test for.
Yeah, let's follow the rules.
Okay.
Make green test, then refactor, and then create yours.
Okay. So yeah, so there is a cycle when you create a failing test and then make it fail, then you fix it and repeat and repeat and repeat. So, but being honest, my experience is that it will be better if you write all the tests that you need, and like you describe all the behavior, and then you can proceed with writing code. So as you wish, Tom. Too evil coder. Yeah, as you wish. Word. And so okay, let's test.
At the very top.
Is it?
Left,
Okay, test. Okay. So yeah, so now it shows that we had we had two tests, yes, two tries, and now we have something working.
So now what do? Now you write tests for me. So you implemented my test. Now it worked. Now you write a test that fails, and I have to complete it.
Okay. I'm too evil coder, and I want you to write me fast Fourier transform. Like, okay, no. Actually, it will be parse. So I want the way to set the world environment to this variable, and this will be something like so we already have world here, and the interesting thing is that you can have different contexts here. Like you can, with this context, you can have different environments for your tests. So you decoupling the test environment. So let's call these contexts, like I will call it a very simple test board of cells, and I will complete it here. And this context will not have any environment, as you see. Like there is only one test there. But I can write contexts, for instance, with existing world. Okay, so and this will and here I can specify the scope that will be accessible by all tests. For instance, I can simply create world. Why? Okay, and this will be world new. So in my test, I can use world that I have created here as a variable, like this. But right now, I want to have a method that is called parse, and this method will accept a string with the description of the world, like how do you do this? Okay. I guess this will be working probably. So here, guess this can be work. Here I will have dots and stars. Yes, like, is it fine? Is it fine for you?
It's your test. I have no idea what are you doing there. Like, this is your test. These are the rules. That's an evil quarter.
Yeah.
That's what we do.
Like this. So we'll have such figure here.
So you're creating string, right? So
yes. This should be.
For everybody. What does it mean? Like this multi-line string Ruby.
Yes, we sometimes we need to
Zoom in.
like this. Yes, was pretty correct.
Nobody got what you.
So let's try testing. So if test will fail, I will know that I'm not that I didn't write it correctly. Okay, so this has a version. Where is my code?
You don't need a version. Get it back.
How? Close?
Yeah.
Close? Are you sure? Okay. So now I run this, and it shows me that okay, so there is confined string world anyway before end of file. So this. Okay, so how to go back? Okay, yeah. So I missed this point, and so we need to provide world here to close this string. Okay. World. Did I? Oops.
Why don't you just have regular double quotes to have multi-line string? Yeah?
I don't want to make plus there. Okay, then. So you can have the way to. So you can concatenate it like this, but also you can. Like you can do it like this. But okay, so. I think that the problem is here. Like, give me a minute, please. Yes, is it correct? Let's try with minus. Okay, made some magic. test. Yes. Okay. Ah. Okay. Let's go and check what they have here. Like we can use Q actually, but this should be working actually. Like
Oh, you can assign it to a string. You can see there.
okay, let's try with this. Uh,
Why don't you use array?
Array of what? That's the good question because I like strings. Like you never know who is where. Okay. Okay.
Why don't you use array? So googling, it is very funny because there is no shame, right? So you don't be like shy googling. Even like Alex can Google for other people. Like sometimes I go to Alex say, oh to Tom, to George, and ask him to Google for me.
and uh, and George will take your finger for that.
Okay.
Okay, so now it's working like this, and like I had a space after the last word, and it didn't parse it correctly. Okay, sorry for that. So, but anyway, I guess this
Anybody understand what George created?
this is okay. I guess this also should work because it should remove these spaces. Test. Okay, this also works. Okay, and the found so now we have test. We have test that tells that Volt have to have method parse, and this method parse accepts string. Do you understand what is these symbols? Yeah, so I had a convention that the cell is a star, a little cell, a little star, and the space, space of voidness is a dot. So, and what I want to do, so here, first of all, I like right now I'm describing the test. I'm describing the method. And I want to create a method. So that does it have? Okay.
Yeah, you can select.
I want to create the method. So you can tap with multi-lines. Okay, cool, great. And I want I want to believe that this method does not fail.
George, why don't you make it simple?
Simple?
Right. So you not to raise.
Not to
Not raise. Okay.
not to not
Check please in the
raise.
there is in the relish doc. If there
Yeah.
it's left on the left top.
Yes.
This one. How to check if it
Raise error. To not to
raise error.
not to raise error. Okay. Okay. Expect not to raise error. So, but and
No man. So that's your test, right? That's your test, and now is my turn because it's evil quarter, George. You remember? Is my turn to fix your test and give you new test.
yeah, sure. And you understand that you understand the output that you have here.
You can keep the microphone because I'm gonna fix it pretty quickly. So now you will see the
it will fail because it accepts string. Okay, and
Okay. Okay, so it accept seed. Let's call this the string that you have.
okay,
It accepts seed. It fixed. And now my turn to write a test for George, and I want his method parse.
we have described method parse here, and you just need to rename it. It does not raise error.
Okay, and and now I want this method. So when you do method parse, maybe it's not the perfect context, right? Because when you get the method parse, right, you want I actually want George to check that there is method.
You need to have another method to check.
To check
Like,
that
yes,
seed is in place. So I
yes,
want
yeah.
to.
You can describe you can take another describe and describe it within. Yeah.
Okay, let's see where is it and describe and then I want to have method seed that returns actually. So seed means that it is the initial state of your world. So when you parse it, you have a file that you parse. Then I want to make sure that when you parse it, this method seed returns your current state. Or maybe if it's not the initial state, I want to get parsing state, right? So I want to get method state.
Seriously? Okay.
Every single tick.
Yes. Yes.
I can get
Okay.
back the world state. So method state returns actual state of the world. And so I want to and here, so this, let me show you what is that. We use spec let. So we use different methods, right? And
You can use before in the. Okay.
yeah, I can actually like instead of having every time code like the same code to create this world again and again and again, we can use actually those helpers to make something once and then just reuse that. So to not repeat ourselves. So in this case, what George created here. So this one, I will refactor it a little bit.
Okay. Okay. Yeah. That's.
So I would have this state state.
You don't need instance for. Okay. Yeah. Okay. Yeah. Yeah. That's correct. You don't need actually you don't need instance variable there because it is already memoized. Yeah. Yeah. And it is. But
And here, world parse state.
okay.
So it's gonna not raise an exception. And world parse. So I do world parse twice, right? So this is actually something that we also can show you. So you see that in our spec, helpers to create instance of the world, create method state, create variable state that we're gonna reuse. Maybe you refactor it, okay.
Okay.
It's gonna be more. In my test that I want George to complete, I parse this world state and I expect that world state to equal state. So what does it do? I parse this string, right? With method parse, which exists here. Right? So parse state. And then it's another method like getter and setter. And I want to make sure that when I parse it, it stores correctly in